In the previous lectures, we were discussing the fundamental types, integral types, and includes the character types as well as the Boolean and enumeration type. We have discussed these things in detail, and what are their size limitations are, and how much space they occupy. In this lecture, what we are going to do is we are going to do some arithmetic operators, so that let me go to here. Okay, so that we know how to add the numbers to perform some numerical calculations, as such as addition, subtraction, and this thing is for multiplication, and this thing is for division, and this is the modulus or the remainder operator. Then we are going to do some increment or decrement operator. Essentially, if you want to add 1 or you have to subtract 1 for counting applications, you will use in the increment or decrement operators. There are essentially two types of increment or decrement operators. They are pre-increment and post-increment. Going to discuss that in this lecture, and then we are going to see how these composite assignment operator works, because we already know that the assignment standard assignment operator is the equals to sign. Then we will see that how these operators work. They essentially update the value. Let's say if we write for example, if we have an integer, for example n equals to 10, then we write n plus equals to 20. So what it does is that in this line is actually equal to n equals to n plus 20. So that means the original value was 10, and this value would be updated, and then now the actual value would be, this evaluation would be evaluated, and this 30 would be assigned to n over here. So that's another way to have an assignment and updation in the same statement. You can do this if you want to, or you can do this. Similarly, if you want to subtract some value from the existing variable, you can use this composite assignment operator, which is read as minus equals to, which means subtract that value and then update that value to the same variable. We're going to do some simple examples. Let's see, go to our let me type the basic structure first, which is include IO stream, and then I'm going to using namespace standard. And I would suggest while you're watching this lecture, you should also somehow type this thing in your code block, so that you have the same practice while doing the lecture, instead of writing the lecture in your copy and then copying it from the copy to the code blocks, or your I'm using dev C++ IDE. If you want to use that, it's okay. So integer main void, and then curly brackets, and return 0. So what I'm going to do is I'm going to do all of these things over here. So let's declare two variables, integer a equals to, for example, 20, and integer b equals to 35, just a number, and then c out equals to there's the values of a equals to, I mean this is a statement over here, so you can just write value of a over here, and then you can write and b equals to just any statement, or you could just write value of b is then c out b, and then and l. So then I'm going to do is I'm going to add these things. I think we have alluded, or we have explained how the addition works. So you can just write a plus b equals to, then write a plus b, and then and l, and the rest of the lines would be just their addition, so, and their subtraction and their remainder. And let's see what we get over here. So control C, control V, oh sorry, we have to do addition, subtraction, multiplication, and what was that? Let me check this notepad. Addition, subtraction, multiplication, division, and remainder. So that's something to do. So that's like 5 operations. So the second operation would be minus, and that would be multiplication, and that would be division. And obviously I mean these are just statements really. So going to These are the mathematical operations. So divide, and this thing would be remainder. So I think remainder, it won't be divided, would it be? No, it won't. Okay, so let's check it out. And that's it. Let's run this thing. F11. What was the last example we did? 20. So let's call this thing e21.cpp. And it says a equals to 20, b equals to 35, just as we did there, and 20 plus 35 is 55, 20 minus 35 is minus 15, 20 into multiplied by 35 is I think 20 into 35 is 700. Okay, and a divided by b is 0. And now why is that? And a percentage b is 20. So let me see, if we can work this thing out. A divided by b is 0. Since a and b both are integers, that means the whole thing, the whole expression would be an integer. So if we divide 20 divided by 35, the answer would be 0 point something. But actually what happened here is that since this thing is an integer and this thing is also an integer, the answer would be an integer, and it will only pick the integer part, and that's why it is picking this 0 over here. So had it been another type which is known as floating point type, we are going to discuss that in the next lecture. This thing, or I mean, if any one of these numbers would have been a floating or a double precision type, which we are going to discuss in the next lecture, so don't worry about it. So it would have picked the it would have upgraded all the types of these numbers. I'm going to demonstrate that in a moment, actually right now, but the details would come in the next lecture, and then we would see the actual result in with the fractional part as well. And the last thing is a percentage b. It is a remainder operator. So remainder operator is whatever the remainder is. Let's take an example. Let's say if you have a number, for example 7, and we divide it by 3. So 3 into 2 is 6, so the remainder is 1. So that would happen if we do 3 percentage 2 or 3 modulus 2 or 3 remainder 2, we would gotten 1. But here a is 20 and b is 35. Since 20 is not divisible by 35 with a whole number, so that means the whole thing, I mean 35, and we put 20 over here, so 0. I mean, if we would have put 1 over here, that would have got 35, so we cannot do that in division. We have to have some equal to a less number over here. So that would be I mean, the remainder would have been 35 into 0 is 0, so the remainder would still remain 20 over here. So that's what we got over here. So let's take another example. Let's go to, I will first demonstrate how this remainder works. So I'm going to out and output operator, and I'm going to type, for example, 7 percentage 3. So we know is or okay, so just write in a statement over here, and going to write 7 percentage 3. And we have to keep in mind that this remainder operator only works with integers. So let's run this thing, and 7 percentage 3 should be equal to 1. That's over here. So this thing is over here. So I think you can see that. Okay, so 7 percentage 3 is 1, and this operator is only applicable to integers only. Rest of the operators are also applicable to fractional numbers. So let's say if I declare, I'm not going to go into too much detail what I'm doing. I'm just changing the type from integer to floating point. Integer is whole numbers, and floating point can have decimal part as well. I mean, can have, should not, I mean, it's not necessary it would have, but it can have. So this thing, so if you're doing this, so in the previous result, let's have the window. Can I have the previous window over here? In the previous result, we got a divided by b was 0. So what I'm going to do is, let's say if one of these in this thing, in this here in this expression, if any one of these type is a bigger type or a floating point type, I mean, all of these things would be upgraded. And let's see what we get over here. I'm going to do the details. Oh yeah, we have an error because it says that view and not this report window. Let's see the report window. It says invalid operand types integer flow to binary operator percentage. Percentage operator is not applicable to the floating point or any number which can contain a decimal part, because it has a different representation in binary format. We are going to discuss that in the next lecture. So let's remark this line, and let's remark this line as well, and see what we get over here, because we just want to see whether we are getting some fractional part when that's here we have it. So A is 20 and B is 35. Now we are getting 0.571459, which is approximately correct, hopefully. So that means the whole expression has now been upgraded to the floating point or the fractional part. We are going to discuss floating point in the next lecture, so don't worry too much about it. So I mean, the point to remember is, if all of these numbers in a division, are integers, the answer would also be an integer. And let's take this number. I mean, if I put 20.02, it has a fractional part as well, but we have declared this as an integer. So that means that A would ideally contain only the 20. It will just ignore it because the type of this number is integer. So if I just write, if I'm going to remark these lines and just to see what we get over here, it says A is 20 and B is 35. So it's not getting the 20.02 part over here. It's only getting the integer part. So if I write float A equals to 20.02, so it will get the whole number, I mean the integer part as well as the fractional part as well over here. So we need to keep that in mind. Okay, so coming back to the, I mean, we have seen how these operators work. I mean, they are applicable to all of the numbers, whether you have decimal part or the fractional part, but this remainder operator is only applicable to the integer numbers only. Okay, so our next topic is in this lecture is the increment and decrement operators. Increment and decrement operators are essentially, if I can write it down, so if I write A plus plus, that means A has some value, so it is actually equals to A equals to A plus 1. If I write A minus minus, this means A equals to A minus 1. It's a short form of writing these expressions. Okay, so if we want to increment a value, and we are going to use this thing extensively whenever we are counting something, or we are counting how many times some code has run, as we will do the topic of loops, we need to figure out how many times some code has run, and we have to have some kind of a counter. So we are going to use this code, or we might be using this code if you are using some increment counters or decrement counters. But there is a slight difference between if you are writing, let's say the value of A is 10, A equals to 10. If I write A plus plus, the A value of A would be now 11. There's a difference where you write this thing. Either you could write A plus plus A, or you could write A plus plus. You could have written minus minus A, or you could have written A minus minus. In all of these cases, one would be added to A and one would be subtracted to A, but there's a difference between where you actually write these plus plus signs or the minus minus signs, whether you have written it pre the variable or post of variable. We call it pre-increment or post-increment, or pre-increment or post-increment, or pre-decrement or post-decrement kind of a thing. So it's a slight difference between these two. So that means that the pre-version, where we have here, let me write over here, the pre-version where you are writing the plus plus or minus minus before that, they are only for adding or subtracting one. So the pre-version, what it does is it either adds one or subtracts one, depending on you have written plus plus or minus minus. Okay, so it makes it, what it does is that it updates the value of that variable, in this case A, or that object, and it updates a value, and it updates a value before that resulting value is used in its surroundings or its surrounding context. Post version, where you have written, I'm going to demonstrate an example. We have written plus plus sign or minus minus sign after that variable. The post version performs the operation the operation is updating the value of a. I mean, if you write a plus plus, it will increment the value of a, but it will do it after the object's current value or existing value has been used. So let me give you an example. Let's say if a equals to 33, if I write if I have a new variable integer b equals to, and I'm going to have the value of b as one more than a. So if I write b plus a, so what happens here is that plus a would update the value of a to 34, and then it will assign it to b. So now the value of b is 34. Okay, so let's take another example. Let's have an integer x equals to 50, and what we do is we have another integer, let's call it integer y equals to a plus plus. So that means that here it was the pre-increment operator, and here it is the post-increment operator. So post-increment operator, what it would do is, what is the existing value of a? Existing value of a is 50, and then it will assign the value of 50 to y, and then it will increment the value of a to 51. So that means in both of these cases, if we print a, if we see out a, we will get, in this case we will get 34, and in this case we will get 51. But if we see out the value of b, we will get 34 over here, but here we will get 50 over here. Let me explain it with a simple example. So what I'm going to do is I'm going to go to the same code, and I'm going to just delete this thing. I'm going to work with integer a equals to 50, and just to figure out, I mean, I'm just going to write value of a is, and I'm going to write a and L. Okay, so now I'm going to write integer b equals to, I mean, you can just declare it and then initialize it, or you can just initialize it to I mean, right here, and a equals to, I mean, I just declare it over here, and I write b equals to a, let me do it first, plus a. Now I'm going to write cout value of a is now, I mean, the updated value. I'm just going to write the updated value of a is now, and I'm going to write a over here, and we'll see what we get over here. And then I write cout value of b is, and just a statement over here, just have written equal to sign, no problem. So b, and see what we get over here. So we have integer b and this thing. So let's run. So I have used the pre-increment operator over here. So value of a is a, that was the initialized value, and integer b, then I mean, I could have done it in the same line as well, so no problem. I could have written integer b equals to plus a, but just to make it clear. Okay, updated value of a is now 51, because in both of these cases, I mean, had it been a pre-increment or post-increment, a value of a would have been updated. But now, I mean, what happens here is it updated the value of a first, and then it is assigned to b. So coming to, okay, what are those windows? Okay, and value of b is 51, and that's what you got over here. So now I'm going to make a little bit of change over here. I'm going to write, so you need to keep that in mind. Value of b is 51, it got the updated value. Now what I'm going to do is I'm going to make a slight change. I made it from pre-increment to post-increment. So as per our understanding is that a value of a, let's start from the very beginning, a is 50, so we should get a equals to 50. Then we declare another variable integer b, type of integer, then we assign the value of a plus to b. So what would happen is this operator is now a post increment operator, because we have written it after a. So what would happen is it will first do the operation, that is b equals to a first. That means the value of a, which is the existing value 50, would be assigned to B, and then it will increment the value of A. So in both of these cases the value of A would be updated, but the value of B would not be 51, it would be 50, because as we have explained it a little bit earlier. Let me run this code first and see what we get. So let me close this window. So press any key, it closes. So let's run this code. So there we have it. Value of A is 50 initially, integer b equals to a plus plus. So updated value of A is 51 because value of A would have been updated anyway, but the value of B is 50. So that means, just to re-emphasize that the pre-version performs the addition or the subtraction. If you have written minus, I'm just going to demonstrate that in a few moments, on the variable or object before the resulting value is used in its surrounding, whatever context that might be. Post increment or decrement version, post means you're writing the plus sign or minus sign after the variable, performs the operation after. Let me repeat that. Post version performs the operation after the object's current value has been used in its surrounding context. So let's try that once more. Let's write this thing as a minus. What will happen is that value of A is 50. After this line, value of A would have been updated, but I mean we should be getting 49 over here. But what would happen is that since it's a post decrement operator, value of existing value of A is 50 would be assigned to B, and then A minus would have happened. So that means let's run this code. So B should be getting 50 over here. Let's see. Value of A is 50, updated value of A is 49. I mean, it had to be, I mean, pre-increment or post-increment both would have updated the value of the object on which the operator is applied, but value of B, the existing value of A would have been applied to B, and then minus operation would have happened over here. So let me write it with this thing, pre-increment operator, and see what we get. So as per our understanding, value of A is 50, integer B. So now this operation would happen first, that A is updated to 49, and then it would have been assigned to B. So let's see, we should be getting the values of A and B. Updated values of A and B should be 49, and there we have it. Value of A is 50, existing value of A is now 49, and value of B is also 49 because the updation happened before the assignment operator over here. Equal to is the assignment operator. So I mean that is actually useful whenever we are talking about the, I mean if we are counting some how many times some code has run, we are going to use this increment or decrement operators a lot. So the last topic in this lecture is the composite assignment operators. A standard assignment operator is this thing. I mean we have just written, I mean this is a simple standard assignment operator. So these are the composite assignment operators. So that would perform the, I mean these will perform, I just explained in the example, this will have performed the operation on that variable and updates the value. And let's take a simple example of let's write integer A equals to some number, for example let's take 50, okay, and we just write C out and just write A equals to, you just write any string over here, or you just written A whatever. So now I'm going to write is A plus equals to for example just a number 7. So what it does is, this is actually equals to, I'm just commenting it, A plus 7. It's just a short form of writing it. So if you want to update the value and then reassign it, if you want to add 7 to A and then update the value of A to it, so the value of A is 50 and you want it to be updated by incrementing it by 7, you just write A plus 7 and then you assign this value to A. So the short form of doing it is like this. So we just write C out value of A is now just write A over here. So I think I'm going to repeat that line, so again and again. So let's copy this line Okay, A, the next operator was, I think, minus. Minus equals to multiply, divided, remainder. Okay, so if you want to do it this thing, so make sure, I mean, the value of A is 57 now here. Okay, so I'm going to write A equal minus plus equals to some number, for example 10. So what would happen is that it's actually doing A equals to A minus 10. So just to emphasize, I'm going to add some space over here. So what I'm going to see the value over here, I'm going to see the value of A as 57. Now what I'm going to see the value over here, 57 minus 10 would be 47. So I'm going to see out this thing, and then the next operator was multiply, I think. So A multiply equals to for example 47, some small number, let's say 5. Okay, so what it does is going to do A equals to A multiplied by 5. So the existing value of A was 47. So what it does is 47 into 5. So I think 5 into 7 is 35, and 235. So the 235 value would have been assigned to A. So the last thing is, so let me write 235 over here. 235. The last thing is A, I think it's the last thing or second last. Let me check. It's 1, 2, 3, 4. Oh, divide and remainder operator. Okay, so A divide equals to for example, just a number, for example 2. Okay, so 2. So that means that the value of A is actually updated to, if you divided A by 2, A by 2. So the value of A would be, if you divide A divided by 2, right, integer A, so that's a tricky part. So if you divide 235 by 2, so the answer is 117.5. Let me check with the calculator. I think it's 117.5. 235 divided by 2, 117.5. But we are assigning this 117.5 to A, and the type of A is integer. I mean, the type actually defines how many bytes that object is going to occupy in the memory, and what operations are performed, or what operations could be performed, or what values it can hold in that location. So integer type signifies that it can only hold whole numbers. So the whole number part, it will actually, the value of A would be 117. We will check it out. So we are going to, oh, I did not print it, so let's print that thing. And we also need to print out this thing. And the last operator is A percentage equals to 117. So let's pick a number. I think it's a prime number. So is it a prime number? I'm not so sure. Okay, so divide by 2, or maybe 3. Let's divide by 5. So we should be getting 20. We should be getting a remainder of 2, because if I divide 117 by 5, I should be getting 20, 21, 22, 23, and 23 point something, 23.4. Let me check it out. So remainder would have been 2. 117 divided by 5 is 23.4. So the remainder would have been 2, so that it, or remainder would have been 2. So point is 4. Yeah, so 5 for the 20. Okay, so I think we should be getting this thing, that we should be getting A equals to what we are doing over here. Sorry, A equals to A percentage 5. So that means the remainder, if I do 117 percentage 5, the remainder would have been 2. So I'm going to get 2 over here. So let's run this code. Hopefully it runs. Value of, oh sorry, I did not put the semicolon over here. Okay, So let's say, I mean, these are just composite assignment operators, nothing special about it. So a equals to 50. Okay, so a is equals to 50, and then we did a plus equals to 7, which is actually updating the value of a, 50 plus 7, and then assigning that value to a. Updating the value, I mean, essentially means assigning the new value, so it's 57. Then we did a minus equals to 10. The value of a is now 57 over here, so that means that 10 minus 57 is 47, and that's what you're getting over here. And then we okay, so a minus this thing is here, and this thing is here. So actually we are seeing this thing printed over here, so we are seeing this thing a is printed over here. Okay, the next value of a plus a multiply equals to 5. That means 47. The existing value was 47, so this thing 47 is into 5 is value of a is now a is updated over here, and the value of a is now 235. And a divided by equals to 2 means that a is updated, and 235 divided by 2 is actually 117, but the type of a is integer, so it only got the whole number part and not the fractional part. Had it been a float, then it would have gotten the, or the double type, then it would have gotten the fractional part. But had it been a float or double, we could not have done this operation. So let's see. And a divided by a percentage or modulus equals to 5 means the remainder. If we divide a 117 and divide by 5, so 5 2, how much is that? 5 2 3 23. 5 into 23 is 115, so the remainder is 2, and that is actually even less than 5, so this is the remainder, and that's what we are seeing over here, So these are the composite assignment operators. So just to summarize, let me go back to mouse settings, or delete this thing. Okay, just to summarize what we have done so far, let me open that. Okay, so we did the simple arithmetic operators, and then we did the arithmetic operator. I think we have discussed that whenever we want to add, subtract, or multiply or divide some numbers, so you could have done that as well. It's not necessary. If you want to assign those two variables, you could have done it right there. So I mean, I could have done like value of a, I mean, if I just write cout 12 plus 3, what would I get? Cout 12 plus 3, so I would be getting 15 over here. I mean, you could just done it in the, I mean, just a number, so just add those numbers. If you want to add some constants and you want to print those values, you can just do it like that. Then we did the increment and the decrement operators. I mean, you have to update the value of some number by, and I think increment and decrement operators are also applicable to only just integers in some implementations. So keep in mind that integers are used for counting. So let's try that. So if we if I do, let's delete, or let's remark the whole thing, and here I think it's all of this thing is remarked, and we have an ending remark over here. So if I write integer a equals to 10, and we need to initialize the value, it's very important. Do not leave a variable uninitialized. So if I write cout a plus plus, what we get? We get 10 over here. Then if we do cout plus plus a, let me delete that line. I hope you understand this thing. This is a post increment operator, so it would have printed the value and it was sent the value to the output stream. The value of A was 10, and after sending the value or using it into the surrounding context, it would have updated the value to 11. Now, so if I write cout A, and let me write and L over here, so we will see what we get over here. So in the first cout, the value of A is 10, but after that the value of A has been incremented. So if I write plus plus A, it would have incremented the value first and then it would have sent it to the output stream. So but one last thing is, if I write float, so let's run this thing. Well, it does run, okay, but it's not a good thing to do to use some floating point numbers for counting purposes, because the reason would become clear in the next lecture. I mean, if you are using whole numbers for counting purposes, yes, you can do that. So but if you are, and you're assigning it as a floating point, but it's not a good practice. The reason is that floating point numbers are not that precise because they have variable precision. So if you are counting whole numbers, so that's okay, but if you are counting some fractional values, you could find yourself in a very big problem. We are going to discuss that in the next lecture. So we could have written it as minus minus. I mean, that would have decremented the value. So I mean, I think that's okay. So let's write minus minus quickly over here and run this thing. So in both of these cases, it would have printed 9 over here. So that's what we got over here. But once again, I'm not going to write float over here. Best way to write is minus integer. Okay, so if I've written A minus minus, so it would have printed 10 in the output stream, and then it would have updated the value to 9. So that is the post decrement operator. And the last thing we did was the standard assignment is just writing the equal to sign here as once. Do not write it twice. That would have been a logical equality check, but just write it once. So whatever expression is here is going to be evaluated, and it would, the resulting value would be assigned to here. So it goes from right to left. The composite assignment is you want to update the value, and the update the value of some variable after adding or subtracting or dividing or multiplying or having a remainder. So then you can write it in short form. If you're not happy with that, you can just write the whole expression if you want to. So it depends really upon you. So that ends our lecture. In the next lecture, we are going to do floating points. So coming back to our original topic, we are going to discuss what these floating point numbers are, and why we call them floating point, and how are they represented in binary numbers in the computer. So that finishes our lecture. See you in next lecture.